There are relationships between rectangular, polar, and complex. So if we just take a look for just a minute at rectangular, we know rectangular comes from this kind of system, and so we have an x and a y. Now, if we want to look at polar, polar has to do with an r and a theta. So if I'm at a point xy, so I went over x and up y, that is rectangular. If I draw this out there and label this theta, this is r. Notice this was y, and the other is x. And so we want to show this relationship between these two positions. We want to get to the same point, whether we're using polar or rectangular. Well, if we set this up, we know the sine of theta is y over r. We know the cosine of theta is x over r. So taking a look at that, y is r sine theta, x is r cosine theta. So looking at the ordered pairs, we see if we have rectangular and polar, they're related. If I know r and theta, if I know polar, I can get to my rectangular. And how would I do that? Well, if I knew polar, I know r and theta. That would give me y. And in the second case scenario, r and theta would give me x. Now let's go the other way, and let's suppose I want to, from xy, go to polar, r theta. What other relationship do I know? Well, I know these two, which are very helpful. And a third relationship that we're going to look at is r, because I need r for polar. How do I find r? From my diagram, r squared equals x squared plus y squared. So in other words, r equals the square root of x squared plus y squared. And then I need a fourth component, xy for rectangular, r theta for polar. So if I look at theta, and if I only know x and y, my rectangular, so if I only know my rectangular x and y, how is that related to theta? Well, that's the tangent. The tangent of theta is equal to y over x. Now, a couple things with tangent of theta. You need to be careful. For example, what if I knew that my y-coordinate was -1 and my x-coordinate was +1? So I had these rectangular coordinates. X is positive, y is negative. If I look on a coordinate system, x, y, it puts me down here. So if I'm looking polar, I'm looking for this type of situation. And I need to find this relationship, r. And let's see, r was equal to the square root of x squared plus y squared, which is the square root of 2. How do I find theta? Well, the tan of theta is equal to y over x. And x is a 1, so that's negative. So in other words, what, when I take and undo the word tangent, do I get 1? Well, that's a 45-degree angle. Tangent of 45 is 1 over 1. Now the problem is it's negative. This value is negative. So looking at the diagram up here, if I want to go to this point, I need this angle here, which is my theta. Well, it can't just be 45 because I need to go down, so it's negative pi over 4, which is 45. But it could also have been up here 3 pi over 4. And that would have been negative if it was that point in quadrant 2. It's in quadrant 4, so what I like to do is just plot the point and say, what quadrant am I in? Find that angle, and that works out. So we have polar to rectangular, rectangular to polar, and now we have this idea of a complex number. Well, a complex number, z, is equal to a plus bi. Looking at a diagram, a plus bi. Plotting it seems easy. Here's a. Here's b. So this axis is bi. So if I draw this in, I again have a triangle. This is A plus BI in the complex number system. Labeling, this is theta and this is R. So in this case, where Z equals A plus BI, A is equal to R cosine theta. How come that is? A is X. We showed that on the earlier screen. B is R sine theta. So let's see, is there a relationship then that I can plug in? Well, I see an A in this case, and I see what A is equal to. So what I can do then is say Z, combining these two, I get R cosine theta plus I R sine theta. And that comes from using these two situations and just inserting it in. And so now I've got this mixture of polar and complex. Got a mixture of polar and complex. Now again, we want to know R in this case, called the modulus. So if I look at R, that's going to be the square root of A squared plus B squared. Now notice where A and B come from. A and B come from A, B, A, B. And then I have this idea of theta again. Looking at theta here. Theta is a tangent is relating B and A, the two pieces that I had here, which are also the A and B on the real and the coefficient on the imaginary part. So if we just took and looked at a situation, let's suppose I had a diagram here, and I was at this point right here, which is 90 degrees. So plugging it in up here to Z, it would be, looking at it, would be R cosine of 90 plus I R sine of 90. Now what is R? Well, R on this circle right here, if this is a unit circle, notice R is equal to 1. So this cosine of 90 plus I sine of 90, because my R's are 1, cosine of 90 is 0 plus I. So looking at that point right here, don't you agree A is nothing and B is out 1? If we try 180, that would put me right here. What would that be in complex? You could look at that and see, well, that should be A negative 1 plus 0I, because I'm not up or down any. Well, again, R is 1. So now I'm taking cosine of 180 plus I sine of 180. The R is not there because it's equal to 1. Cosine of 180 is negative 1. Sine of 180 is 0. And notice they match. So if you just go back and look, it all comes from a diagram and a triangle and noting what each of them are. It all deals with theta, AB, which is also XY, and R. So what you need to know for the test is how to convert all these. So you need to know this. You need to know that R is a modulus and how to compute it. You also need to recognize how to find theta. Now again, it matters the quadrant you're in. Where did this all come from? It all came from that triangle. So if we go back and look here, you need to know how to convert from polar to rectangular and rectangular to polar. And it's all based on those relationships. All comes from a triangle within a circle.